doing activity B of day 4.
Cool. I'm also here, Joachim.
I'm here, Matt.
Okay.
So
I don't know if I should say last names. Those are groups, right?
probably not. We know each other.
I'll
So
just post like later anyway. Like when I send it in to them, I'll just include all the names. All right.
So I guess question
have-
number 1. Like this, for me, this stuff's really hard. It's like incredibly hard to understand.
Okay.
And so I don't really. I guess where would you guys get started on that question?
So have you guys?
So, go ahead.
Okay. So what I did, like I've read the chapter for this.
Uh-huh.
I mean, I do get it because I've already done the homework and all that.
Okay.
Essentially the same stuff. But it helped to read through the text for it. It's chapter 18, derivatives of trig functions. And it basically gives you all the formulas for like what the derivative of cotangent x is, of what tangent x is, and so on. It's really not that hard.
Okay. It's just you just need to know those formulas and.
Yeah, and I have them up here as we go because I don't have them memorized.
Okay.
Do you guys have that paper I emailed you?
Yes, I haven't printed it yet, but I'm going.
Me either.
Once.
So that has all of those on
All
there
right,
as well.
I'll just put it out right away, I think. So with the first one, you can tell that you have to use the product rule there.
Uh-huh. So we'll take the derivative of x to the negative 9th and then the derivative of cotangent of x. And then add. But yeah, using the product rule.
Yeah. So you take x negative 9 up to the negative 9, then derivative of cotangent x plus cotangent x, and then the derivative of x to the negative 9.
9x is 10.
Wait, say that again? I thought I had this, and now I...
So you take the derivative, so it's the product rule, right?
Yeah.
The derivative, no, first you just leave x negative 9, you leave it. And then you take the derivative of cotangent x.
Okay.
And then plus. And then it's cotangent x times the derivative of negative 9. Or the x to the negative 9.
Is that negative 1/9 x to the 9th? Did I do that right?
Negative 9x to the negative 10.
10.
Yeah, or...
Oh. Okay.
So you'll just bring that exponent down and then add, I guess, subtract 1 more.
So in like a simplified form, what I get is... hold on. I get negative cosecant squared x divided by x to the 9th power minus 9 cotangent x divided by x to the 10th power.
That's what I got as well.
Cool.
I guess that's not that bad. It's just
Yeah,
understanding those formulas.
right. So, yeah.
Does that make sense, Matt?
Yeah, it does. It's just a matter of learning, like you said,
Uh,
learning the formulas.
yeah.
Let me. I'm gonna
Okay.
print this off so I have it. I started laminating important forms. It's been
Oh,
nice.
that
Oh,
works out.
I only did that to like the periodic table I got a few semesters
Oh,
ago.
I inherited a laminator, so it doesn't cost me anything to do it.
Well, that's nice.
Yeah. Anyway, okay, so let's move on to the next one then.
Cool.
Hold on a second.
So we'll leave cosecant there, and then take and then multiply that by the derivative of cotangent,
Yep.
which is cosine x over sine of x, correct?
Yeah, that's what I have here.
Yeah, but that's just the formula. That's not the
Okay.
derivative.
Oh, yeah. Okay, I was looking at the wrong part. So it's negative cosecant squared x. CSC squared x.
Oh, okay, below it. Okay.
Yeah, I did the same thing. In the box right below it.
like, where are you seeing this? Yeah, okay, that makes sense.
And so
I
then
mean,
you'll
you
take.
can do it like that. You can also divide them up and like take the derivative of sine and cosine in like a quotient rule or something like that. But
Mm-hmm.
I mean, it's simpler this way, I think. And then plus what?
Plus negative cosecant of x times cotangent of x times because
Wait,
the
wait, what do
derivative.
you have so far?
So starting from the first, I have cosecant of x minus cosecant squared of x.
Okay, they're multiplied,
Oh yeah,
but
yeah, yeah. Sorry. Multiplied by a negative cosecant of squared of x
uh-huh.
plus negative cosecant x times cotangent of x, and then it'll be times another cotangent of x, correct?
Isn't it plus? No, wait. Plus cos.
Let's see.
So I guess on the second half of the product rule,
Yeah, okay, I see what you're
so we'll
doing.
take the derivative of cosecant, which is negative cosecant x times cotangent of x, and then multiplied by the cotangent of x again. And then just simplify that.
So I got negative cosecant to the third power x minus cosecant x and cotangent to x, like to the second power x.
Yes, I think that's what I'm going to get. I'm just putting it all together. Yeah, that's what I got. I guess, does that make sense to you as well, Matt?
I slowed down to try and understand it. Hold on, sorry.
No, you're good.
So wait, this is the u multiplied by v rule that we're doing, right?
It's just the quotient rule again. You don't need the UV, DVU, or whatever it is.
Oh, that's not what we're doing on
No,
this?
no, no. That has to do with integrals.
Oh, okay.
And this is just u times v.
That's why I'm.
Yes. Yeah, it's u times v, I think. The product rule.
Oh, yeah. Okay. Okay. That is okay. So we have cosecant multiplied by what is that? Cosecant squared of x. Sorry, of x. Um,
And then you'll do plus the derivative of the first one times the second one.
yeah. Let's see. Cotangent is plus negative cosecant of x.
Mm-hmm.
Is that right? No.
Yes. Yes.
Yeah.
Okay. Okay. And then what did you guys wind up getting for your solution?
So I got negative cosecant of x times cotangent squared of x minus cosecant to the third of x.
Same here.
Hmm. I'm not getting that. Hold on.
So I guess how far are you right now? What do you have written down, Matt?
Well, I tried it and got it wrong, so I erased everything and started over.
Okay.
That's not,
I'm gonna pull out scratch paper and work on that. Okay, so
Hey.
we have
Did it take you long to do yesterday's homework?
yes.
Me too.
Yeah.
That took like half a day.
Really? It was brutal.
All right, so let me see if I've got this right. So I've got cosecant of x multiplied by cosecant squared of x
Yes.
Mm-hmm.
plus cotangent of x
Okay, so you have the
multiplied.
negative cosecant squared of x.
Yes, that is important. Okay, plus cotangent of x multiplied by negative cosecant of x
Yes.
multiplied by cotangent of x, correct?
Yes.
Okay. And what did you say you got for the solution?
Negative cosecant of x times cotangent squared of x minus cosecant to the third of x. So I guess I flipped sides
Okay.
on both
Yeah.
of them.
I
They
know.
just flipped orders.
Yeah, no, I actually I do get the same thing. Yeah, I think that was the problem is I did have it backwards from what you were saying.
Okay, but yeah, sorry.
Yes. So no, it's fine. It's the same. I just I
Yeah,
had it
you're good.
reversed. Just throw me off.
Wait.
Okay. Let's move on then.
So number 3.
Sounds good.
Okay. So we have.
Here's the quotient rule.
Okay, I don't know if I did this right, but I don't think I did this right, but we'll see. X minus 1 over secant x plus tangent x squared.
Hold on. Wait. What were you saying? So
So I don't think I did this right. Hold on.
I'm trying to write this all on the paper. I realize I'm gonna need some more space.
Yeah, for sure.
Yeah, there's not enough room on that paper.
Makes sense. That turns out to be a long problem.
Yeah. Well. So have you written it up when you have like x and then like the derivative of the bottom?
Yes. So I have it written up as the quotient rule. I haven't simplified it yet.
Yeah, but how do you multiply in x?
I think you just multiply each one of them by that. So it'd be like,
When it's sec x tan x, you have two x's. And do you get like an x squared then? Not you don't
well,
get secant x squared. No, you
well,
don't get secant
I
squared.
think you have to put the x in front of it, because if you do like the x squared, that would change your number. That would be your final number, you know.
Oh, I don't know. Yeah.
So I don't think you can really well, you
Okay,
probably
where-
could, but I don't know if I'd simplify it any further than that. I'd just leave the x on the outside.
I think I started this problem all wrong.
Yeah. Yeah, I think you're right.
So I guess do you understand the quotient rule, Matt?
Yeah, this is v prime u minus u prime v over v squared, right?
Yes, yes. So
Okay.
you'll take, for me, I took my x times, so I took the derivative of the top times the derivative of the bottom, which would be 1 parentheses secant x plus tangent of x parentheses, and then I did multiplied by the top x, multiply the top x by the derivative of the bottom, and so that turns into x parentheses secant x tangent of x plus secant squared of x. And then you divide all of that by the bottom squared, so secant x plus tangent of x squared.
I have that as simplified as it can get. Like secant x plus tangent x minus x secant x tangent x minus x secant squared x, all divided by secant x plus tangent x squared.
Yes.
That's as far as we can get.
Yeah, I don't think it goes any further than that. I guess.
Yeah,
Let
see,
me
that's
look
where I
at.
had gotten, but okay.
Did you get that?
Yeah, I got to where you were at, but
Yeah, that's
I
as
don't know.
go, I believe.
Okay. Yeah, this is a head scratcher.
Huh?
Well, so this is what I don't like about this type of math is where you're not trying to find a solution, you're just trying to rewrite the problem.
Yeah, I know.
Like it's like a judgment. Like that looks done. Let's move on to the next one.
I know.
I don't know.
Yeah, everybody just looks at it differently.
Do you remember
I
in
guess.
calculus when you had these problems and had to rewrite them to like simplify them?
Do you remember what?
Like in pre-calculus,
Oh,
you had to
yes.
take all the identities and like rewrite them and like, oh, that was a pain.
I remember that.
All right, should we start 4?
Yeah, I'm good with number 4.
Yeah, let's move on.
It's the quotient rule here too, right?
Yes.
And note that the root x is just over the x, not over the 1.
Okay.
Yeah, got it.
I guess I've got it, but mine's still pretty long, and I don't know. I don't know if you can really simplify that either. Are you doing okay, Matt?
Yeah, just writing it out.
Okay.
Yeah. So I multiplied it out.
Uh-huh.
The x plus 1. I'd say just keep it as that. It's simpler, more simple,
Okay.
I'd say.
Okay. Can you guys tell me if I'm at least right at this part? where it's
Yeah, for sure.
root x plus 1 multiplied by secant of x tangent of x minus by secant of x times 1/2 x over negative 1/2. That part I'm not positive on. And then all over root x plus 1 squared. Did I lay this out right?
Yes, all except that. What was that the thing that you were not sure about? Say that again.
The tangent, or not the tangent, the derivative of root x plus 1,
Yeah.
is that 1/2 x to the negative 1/2 power?
Yeah. Okay. Yeah. You're good.
Okay.
Yeah.
Well, cool.
Can this be simplified any more than that?
Um. I mean, I just write the 1/2 x to the negative half power as 1/2 root x.
Oh, okay.
But I don't know. You
That's
can
the
do it
same
whatever
thing.
way you want. I don't think
Yeah.
it's better than the other.
Yeah.
Now,
Whatever way you see
technically,
it.
can't we get rid
Better.
of root?
What
Can't
do
we
you
get
think?
rid of root x plus 1 on the? Sorry, can't we get rid of root x plus 1 on the top and one of the squares on the and one of the root x plus 1 on the bottom? Because when you're dealing with powers, isn't that subtraction?
Yeah, you can, but in that case, you got to do it to both sides.
Oh, I
Like,
see. You're
yeah,
right. Yeah, never mind. So we'd be left with a negative. Okay, yeah, it's not worth it.
yeah, it's more complicating, I think. But yeah, it's if you had one of those on the other side as well, we could definitely do that.
Gotcha. Okay,
Next one, that one shouldn't be too hard.
let's do it. All right, let's see.
Oh yeah. Okay, so here's kind of like the chain rule,
Uh-huh.
because we have the squared. So like we bring down the square, so like 2 cosecant, and then 2 cosecant x, and then we take the derivative of cosecant x.
Oh, that's right. Okay.
So it's two different parts.
Yeah, it's like the chain rule.
So it'd be 2 cosecant x minus hold on. Multiplied by, sorry, negative cosecant cotangent, would that be square of x?
Huh?
I don't know if I did that right. Is that right?
Say that again.
So 2 cosecant x
Mm-hmm.
multiplied by negative cosecant cotangent, and then I put square of x?
No, not squared, just x. So,
Okay.
but you got it in the beginning. So like 2 cosecant x times negative cosecant of cotangent x. The reason is because we're just taking the derivative of the cosecant x after, because that's basically our end
Oh,
solution. Because we've already
gotcha. That makes sense.
We're peeling back the onion layers.
Yep.
And crying the whole time. Okay.
Yep.
So that's it, right? We can't go any further than that.
No, and then then you multiply it out. So like you get negative 2 cosecant squared x cotangent x.
Gotcha.
Perfect. The next one seems pretty nice.
Yep.
You guys good on that one?
Yep. Got
I
it.
got secant of x times tangent of x minus secant squared of x.
Yep.
I guess I don't know. Maybe I have dyslexia. I started working on 9, but under 6. Don't
Oh.
judge me. Go ahead, judge me. It's all right.
Hey, you're good.
I'm like, how are you guys getting
9.
this?
9. 9. That's not even trig. What in the world? You see that?
Yeah, what's she doing to us on number 9?
I know. Oh well. Guess they're just throwing one in there.
Yeah.
Here's a review problem. Did you guys do good on the test?
Does she have her grades out yet?
I haven't got it.
I haven't got mine either, but I don't know yet. I'm kind of worried.
Oh really?
Yeah. I don't think I was. I didn't do as good as I would have liked to, but I don't think I did that bad.
The only thing that I was kind of like unsure of, that was that that sphere. Remember there was the sphere or something, the increasing radius.
Oh,
Anyway.
the balloon, yeah.
Oh yeah. I didn't like any of those questions on that page. I'm not very good at those ones.
Yeah, I don't know. I think I finally got the linearization after like a while of thinking about it.
When did you actually end up taking the test?
On Monday.
You took it on Monday?
Mhm. Yeah. Well, yeah. They didn't send it out last week, so I sent an email and then they let me take it Monday. Anyway, we gotta get done with this though.
Number 7?
Yeah.
So,
Okay. So then we got the product rule and then the sum rule.
Okay. Let me know what you guys get.
You're good?
Yeah, I got 2x of secant squared x plus secant squared, or, no, hold on. I never remember how to read these. Cosecant, there we go. Cosecant squared x. So 2x secant squared x plus cosecant squared x.
Wait, say that again. So you got
2x
uh-huh.
multiplied by secant squared of x.
Okay, there I think you need to do you take the derivative of one of them. I think you took both there.
I did. Oh, I see what I did wrong. Okay.
And then the next one you take the opposite.
So what did you get?
I got x squared secant squared x plus 2x tangent x minus cosecant squared x.
Yep.
Okay.
Oh, yeah.
Number. Are you good on that one, Matt?
Yeah, I am.
Okay. Number 8. So would you just do the sum rule and then the product rule?
You multiply them out and then do the product rule plus.
Okay.
Yeah, essentially, yeah.
Okay.
Okay. I think I got it.
I think so too, but I didn't really simplify it a whole lot.
Oh, wait.
Let's see you.
Thank you.
Yep. Yeah, I got it. I'm checking my answers with the key, and I mean, I've written it a little bit differently, but it's the same thing. So what did you guys get?
So I got negative 5x to the negative 6 plus 42x to the 5th
Wait. Negative 5x
to the negative 6
Okay.
plus 42x to the 5th,
Mm-hmm.
all multiplied by the cosecant of x, and then plus parentheses x to the negative 5th plus 7x to the 6th parentheses multiplied by the cosecant of x times the cotangent of x.
Say that last one.
So the second half of the product
Yeah.
rule, so parentheses x to the negative 5th plus 7x to the 6th, close that parentheses, all that multiplied by the cosecant of x times the cotangent of
Okay.
x.
So I have the same thing as you do, but everything is multiplied
Okay.
out.
Oh, okay.
Yeah, I have them all multiplied as well.
Okay.
So I didn't multiply it all out at the beginning. I left the 1/2. I left the numbers on the one side, and then did the cosecant of x. Took the derivative of that.
Okay, I guess that's good. I multiplied it out, so that's why I got what I got. Okay, I suppose we can do both ways.
Yeah.
Yeah, that's smart, actually. Cool, let's do 9.
Number 9.
Alright, well, that's just dual derivatives. Got the chain rule first.
Matt's already ahead of us. He already did this one 2 problems ago.
No, well, no, I started it and I didn't get very far when you started saying. I'm like, wait, what's going on? These are not even close to where I'm getting.
Okay.
Are you guys good?
What? Why does it? Oh.
Yeah, but I don't think I have
Yeah,
it finished.
But
It's I don't really.
Oh,
I don't know how to do this one really very well either.
I'm one off. I don't understand the ending. It looks like.
okay. Well, so what they did, I did it differently than the answer key. So I took I think what they've done here is is that they have multiplied the root by the x5, so it's like x to the fifth to 2/5.
Uh-huh.
Well, yeah, that's what I've written. I went and had like x to the fifth to the half power and took the chain rule,
Okay.
and
Which
it gave me 5. It's the same thing. I got the same answer. It's 5x4 over 2 times the root of x5. And that's the same answer. So plus 21 over x8.
you got 5.
So
Oh,
5
I see.
to
Okay.
the fourth
Yeah.
over 2 times the square root of x5. The square root of x5 is x to the 5 divided by 2. And if you divide the exponents, or divide them, like you take 4 minus 5 over 2, you get 3 over 2. So that would be 5 over 2 x 3 over 2. So that's the same number. But yeah.
Okay. I guess. So
You
I had
can-
gotten to 5/2 multiplied by x to the 3/2 power plus 21x to the -8th, but they convert 21x to the -8th back to a fraction,
Yeah.
and that I missed that part.
That's okay.
Well, yeah, I think it's the same.
It's the same
It's
thing.
just, yeah, it's however you want to look at it.
Yeah.
I don't know. It's whatever you prefer.
Yeah.
You get right for both answers, I think. Ooh.
Yeah, I mean, it is the same. It's just a matter of like what the teacher considers to be finished.
Yeah.
Number 10.
Wow, we're only halfway
Hey.
done.
Hopefully they start going a little faster.
Yeah. Do we have to do the whole assignment though?
You know, I don't know.
I don't think so. I guess all that it really says it doesn't really say much about group meetings on here. It just says meet with your groups.
Yeah.
I mean,
But
this is. Go ahead.
I mean,
I
if you
guess
guys
like.
do
No,
it-
go ahead. Sorry.
How much time do you guys have?
All day.
Yeah, technically all day. But at the same time, we've been at this an hour. Do you think the teacher really cares if we were just to say, all right, that's our meeting, guys. Everybody
Well,
do
I
your
mean,
thing?
we're supposed to do one assignment, but I mean, this is a quite long assignment.
Yeah.
And I think we all kind of understand it. Like we've been able to teach each other enough now
Yeah.
that we can work through
Yeah.
it. I think that's really like the main goal of working together.
Just for me, like I see these problems, and there's nothing really new here
Yeah.
that I feel like I need to work on.
Yeah, for
But, I
sure.
mean, if you guys want to keep
Yeah.
going, I'm fine with that.
I'm fine. I think I understand it well enough that I could do it by myself now. So
Yeah, I'm in the same boat.
it's just.
As long as I'm looking at the right problem, I think I'll be.
Yeah. So do we
So,
want
yeah.
to call it good there, or?
Yeah, I'd say that's good.
Yeah,
All
I'd say
right,
so.
stop.